Hi, I'm an old guy and I do maths, and today we're going to have a very quick look at a very simple form of Dijkstra's algorithm. Now, Dijkstra's algorithm is a means by which you find your way through a network from start to whatever destination is chosen with as few miles or hours or whatever the weightings represent. Now, we have a very simple network here. We're looking for the shortest path from A to D. I'll spoil the surprise. It's A, B, D. That's it. But what Dijkstra's algorithm allows us to do is to eliminate all the other possible ways in which we could do this. And I've already done this because there's a lot of talking and explaining involved. And I'm one of those people who really sometimes struggles to write and talk. So here we go. Step one, which you can see down here. We set out our starting point here, which is A, and then we name the other vertices or nodes on this network, B, C, D, and E. Now, it's possible to get from A to D in all sorts of ways. We can go via C and E, and we'll see later on in this how we eliminate that possibility. Okay, so what do we do? Well, we set this up like this. Then we take a look at our network and we look at A and we say, what are the ways that we can move from A to somewhere else? And we can move from A to B and A to C. The shorter route is A to B. So with nothing else in the offering, we put a box around A to B, which is 13. These little X's, they're here because that is the way that some of my students do this. And quite often you'll see an infinity sign in here. You'll also see subscripts of A, B, and C as we work through this. I don't think it gets a bit crowded if one does that, so I've done my working off to the side. Okay, so that's our first step. We know that the shorter route out of A is to B, and it's got a weighting of 13. Now we take a look at B, and there are two things that we can do. We can move from B to D, which of course solves the problem, or we can move from B to C, which does not solve the problem. As I said, the surprise has been spoiled, but this deserves an explanation. So, what's going on? Okay, well, we bring the 13 down to this row where we are working from B now, and we take a look at the two routes out of B. We take a critical look at them, and we see that B to D is 15. B to C is 26. Now, B to D here is marked as 28. Why is that? Well, we do a calculation based on the shortest route out of A and the shortest route out of B, or the shorter in this case. 13 and 15 is 28. That's A plus B. Now another option is A to B plus C. So that's A plus C. So that's that and that. That gives us 39. That's out of the question. So what we do is we choose the shorter of these out of B and we place it here. And because there's no direct route from B to E, we place another X. And so at the moment we're looking at 13 and 15 being the shortest route. Okay, so let's move on down. And this is where we're going to get a conclusion. And I'm sorry this is messy, but I've got some working in here. Right. So the row A is the same as you see here. The row B is the same as you see here. These arrows indicate the route that I discovered. Now, we go to C. Just in case, by some miracle, we can go A, B, C, E, D, or A, C, D, or something like that. We're just checking. Okay, now, the shortest route from C to D is this one here, 23, I think, 14 and 18, yes. That's also out of the question. So let's take a look at what that means. So I've done a couple of calculations here. C plus D gives us a total of 38. That's not feasible. C plus E gives us 14, and we still have to worry about 18. But as it turns out, C plus E from A, we're always working from A, C plus E, if I show it here, C plus E, that line and that line, gives us a total of 29. So C to E we can put in here, 29. We'll put in the smallest value. Now, as it turns out, we still haven't reached our destination with a value of 29, but over here we have reached our destination with a value of 28, and because 28 is less than 9, we bring the unboxed value of this down from row B and put it in row C and put a box around it. We're at our destination. Now, how do we work backwards and go through the route? Well, we work up from here to this row, then across to this row through this value here, which is 15, and back up to A. So the answer is that 13 plus 15 gives us 28, which is the shortest route from A to D. And as I showed you earlier, when I spoilt the surprise, that is it. Okay, now that's a very quick overview of Dijkstra's algorithm using a tabular form. As I said, it's not my favorite way of doing this. What I tend to do is I tend to put two little boxes on each of the nodes and just work through that. And there's going to be a video in the playlist on how I do that. That seems to be the more popular method amongst those who I do teach. But as I say, this came up from a couple of students, and I think they may have the same teacher, because I do know that other classes in that school are not using this method. So there we go. Anyway, I hope that was helpful. And if it was, please like and subscribe, and I'll see you next time. Bye.